In this episode, the most audacious spacecraft in history.
The Space Launch System will be the most powerful rocket that's ever left the face of the Earth.
Constructed to transport humans further than ever before.
Once we finally do it, we could look back and say it's the greatest thing we've achieved.
And the pioneering historic innovations.
This is really cool. This is like going back in time.
That made the impossible
This is an incredible piece of engineering.
possible.
Four, three, two, one.
For over half a century, NASA has been at the cutting edge of manned space travel. From the pioneering lunar adventures of Apollo to the epic technology of the International Space Station. Its engineers have strived to innovate. But now, NASA is undertaking a new project with the extraordinary goal of taking man to Mars.
Mars is like the holy grail of space exploration. We're going farther than we've ever gone before, into deep space, uncharted territory.
And to achieve this, engineers are having to think big as they attempt to create the most advanced spacecraft ever built.
Orion is just a huge engineering feat. There are thousands of people that are working very hard to make Orion a success.
The best engineers in the world are all working right here on this project. This isn't easy. We're going to space. If it was easy, everybody would be doing it.
The core of this revolutionary spacecraft will be the crew capsule. Measuring 5 meters in diameter, it will be the largest NASA has ever built, accommodating up to 4 astronauts. Once in space, Orion's powerhouse will be a state-of-the-art service module, equipped with unique life support and propulsion systems, and 4 winged solar arrays spanning 19 meters across, which will collect energy from the sun, allowing Orion to travel further than any exploration vehicle in history. For NASA Crew Module Manager Lara Kearney, Orion's unprecedented voyages into deep space will have an epic purpose.
I think it's important to learn about the other planets we have in our solar system, how they were formed, and whether we might be able to live there, and to be able to answer the question, ultimately, if we're alone in this world.
But the first huge hurdle facing Lara and the team at NASA is how to create enough power to even get Orion off the ground.
And when you fly a mission like that, you have to take a lot of components with you, a lot of equipment. With that crew, they're going to be gone a long time. In order to push all of that equipment a long way away, it has to be very powerful.
To make their launch a real possibility, Orion's engineers will need to look back to daring innovators of the past for inspiration. As long as man has looked up at the heavens, he's dreamt of traveling to the stars. In the 2nd century AD, an ancient Mesopotamian scribe wrote about a ship blown to the moon by a storm. But according to legend, in the 1500s, it was a Chinese astrologer, Wan Hu, who became the first person to try to reach the moon using rockets, traveling in a chair powered by gunpowder. Once the smoke cleared, he was nowhere to be seen. Whether he made it into space remains a mystery. It would take the genius of American engineer Robert H. Goddard in the early 20th century to turn the seemingly impossible dream of a rocket powerful enough to leave the Earth's atmosphere into a reality. Space historian Amy Shearer Teitel is joining the Albuquerque Rocket Society in Roswell, New Mexico, as they look to recreate one of Goddard's landmark engineering feats.
This rocket is a replica of the A5 built by rocket pioneer Robert Goddard in 1935. And it was in this desert landscape away from populated areas that Goddard was first able to fire his rockets to really show how powerful they were.
Fascinated by space travel as a child, in 1915 he'd launched his first rocket. But the gunpowder that fueled his early prototypes was an extremely inefficient means of propulsion.
He knew that to ultimately leave the pull of the Earth's gravity, he would need a far more powerful fuel source. And so he turned to liquid propulsion, a mix of gasoline and liquid oxygen that would burn with a hotter reaction and create a more powerful rocket.
Burning gasoline and liquid oxygen together in a combustion chamber created a high-pressure, high-velocity stream of hot gas. Passing it up through two pipes and down a nozzle accelerated the flow of the gas more, producing thrust to propel the rocket upward. The higher the temperature, the greater the thrust.
And this is actually a replica of his 1926 rocket that he used as a proof of concept demonstration of the power of liquid propulsion. He named it Nell, and it flew 41 feet in just 2 seconds before it crashed.
It was a small but incredibly significant flight. Goddard had created the blueprint for all modern rockets. In 1920, he published a paper claiming his designs could be used to send payloads to the moon. Not everyone agreed. Called absurd by the New York Times, his ideas flew in the face of the accepted scientific views.
Scientists believe that because there's no air in space, there would be nothing for a rocket to push against, so it wouldn't be able to fly. But Goddard had other ideas.
Thanks to one of the most basic laws of physics, written by Sir Isaac Newton in 1686. It stated that for every action, there is an equal and opposite reaction. Unlike his contemporaries, Goddard believed this theory would apply in the vacuum of space.
So here's Newton's third law of motion in action. Imagine the skateboard is the rocket, and the medicine ball is the hot exhaust gases escaping from that rocket. As I throw it forward, the force of me throwing the medicine ball will propel me backwards with the same force in the opposite direction. So here we go. That's Newton's third law in action.
Inspired to push the boundaries, during a 15-year period, Goddard launched 34 liquid-fueled rockets, ultimately reaching altitudes as high as 2.5 kilometers and speeds approaching 1,200 kilometers an hour. And today, having been faithfully replicated, one of his engineering masterpieces, the A5 rocket, is set to launch in the New Mexican desert.
So this is really cool. This is like going back in time. This is it. 5, 4, 3, 2, 1. That's amazing! Oh, this is really incredible. You can just imagine Robert Goddard and his team being out here doing this exact same thing 80 years ago.
Robert Goddard truly changed the face of rocket design and made the seemingly impossible possible.
He researched, developed, and understood the basic fundamental principles of modern spaceflight and developed the rockets to make it happen. Without Goddard's contribution, human spaceflight would still be just a dream.
To launch Orion into deep space, NASA's engineers are having to take Goddard's ingenious concept and supercharge it.
8.4 million pounds of thrust. It's taller than the Statue of Liberty, longer than a football field.
As work commences at the New Orleans Michoud Assembly Facility in 2012, Pat Whips is tasked with building the monster rocket that will first be used to send Orion on 2 test missions beyond low Earth orbit.
The Space Launch System rocket will be the most powerful rocket that's ever left the face of the Earth.
Capable of carrying a payload of 70 metric tons, 2 solid rocket boosters, the largest ever built, will generate over 75% of its thrust. The rocket's core stage, a giant fuel tank, will store cryogenic liquid hydrogen and liquid oxygen to power 4 RS-25 engines, originally designed for the Space Shuttle program.
The engineering that's gone into these engines is just incredible. I call them the Mona Lisa of mechanical engineering.
Steve Wofford heads up the team testing the Space Launch System's engines at the Stennis Rocket Facility in Mississippi.
To be able to do what they do with the efficiency that they do and harness that incredible amount of energy and produce the power that they do, it just astonishes me. I've been in love with these engines for over 25 years now.
These colossal engines are complemented by 2 gigantic 55-meter rocket boosters. In March 2015, testing begins in the Utah desert. During the 2-minute burn, engineers successfully collect data on 103 design objectives. The world's largest solid rocket motor generates a jaw-dropping 3.6 million pounds of thrust, the equivalent of 14 jumbo jets at maximum power.
These engines will get to orbital velocity of 17,500 miles per hour, which is about Mach 25.
But to eventually make its monumental journey to Mars, NASA's engineers are already devising an even more powerful version of the rocket system.
In just a few more years down the road, our 130 metric ton version of the Space Launch System will be able to take nearly 140 tons of payload, ultimately taking habitats and equipment and, of course, astronauts to the surface of Mars.
But to build a spacecraft capable of transporting man further than ever before, NASA's engineers still face major challenges and will have to draw on more innovations from the past.
They really were incredibly brave pioneers of their time.
To produce their impossible engineering. After more than half a century of space travel, NASA is undertaking its most daring project to date. Aeronautical engineers are building a new craft that will enable man to explore deep space.
Orion is going farther than humans have ever gone before.
The goal, by 2035, to land a team of astronauts on the surface of Mars.
Space is obviously a very aggressive place to be, so there are a lot of challenges.
Everything needs to work. Failure is unacceptable.
With its first manned mission scheduled for 2021, crew module manager Lara Kearney and her team have a huge problem. How to create a capsule that will ultimately have to keep its astronauts alive up to 100 million kilometers from home.
Human beings are not meant to live in space, so we have to deal with the vacuum of space, the extreme temperature conditions, the zero gravity environment, things that the human body is not used to while they're here on Earth.
Providing a safe habitat for Orion's crew would have been an impossible engineering challenge without the great innovators of history. Since the first manned launch in 1783, balloonists wanted to go higher and higher. And when, in 1899, French meteorologist Léon Tézerac de Bourg sent his weather balloons into the stratosphere, the daring aeronauts of the day were desperate to reach these dizzying heights, but soon found out their bodies simply couldn't cope. Today, Dr. Andrew Steele is treading in the footsteps of these fearless pioneers as he takes to the skies.
This is amazing. It's an incredible view. And to think that pioneering aviators would make high-altitude flights in balloons not dissimilar to this one. They rapidly discovered that the atmosphere changes dramatically as you go up. The air gets a lot colder, but it also gets a lot thinner. It gets much harder to breathe. And that's because as the pressure goes down, the oxygen molecules are more spread out, and you just can't breathe deeply or fast enough to compensate for that.
By the end of the 1920s, daring aeronauts had reached as far as 12,000 meters with the aid of oxygen. But even more extreme physiological problems were holding them back.
So what happens to your body as you go up to 12,000 meters and approach the vacuum of space? Well, I don't really want to try that myself, so I've got a little marshmallow man who's going to demonstrate it for me.
As today's flight is only hovering around 600 meters, a vacuum jar and pump are the perfect way to simulate high altitude's unforgiving low-pressure conditions.
You can see now that as we're sucking the air out of the vacuum jar, the marshmallows are starting to expand, and that's because they contain little pockets of air. And as the pressure on the outside of the marshmallows fall, those little pockets of air start to expand. Now, if that was me going up to ever higher altitude closer to that vacuum, then the pockets of gas inside my body would start to expand. And as we got to really low pressure, fluids on my exterior would start to boil. Poor guy. What I'm going to do is turn off the pump and then let the air back in. And you can see that as the pressure increases again back in that jar, it squishes him back down to his normal size. Though I don't think he's ever going to be his former self again.
Travelling higher seemed like an impossible challenge for the world's pioneering aeronauts. Until, in 1930, daring scientist Auguste Piccard proposed an audacious solution. Hidden away in the depths of the Science Museum's storage facility lies a groundbreaking craft that finally transported man safely into the stratosphere.
Piccard wanted to travel high into the atmosphere to study cosmic rays, and he didn't want to work wearing a cumbersome oxygen mask. So he knew if he was going to do this and survive, he was going to have to take the Earth's atmosphere with him. He came up with the notion of a pressurized capsule.
To get his genius design totally airtight, Piccard turned to a local beer barrel manufacturer to create his innovative two-man gondola.
The capsule is just over 2 meters in diameter, and to keep it as light as possible, it's made from aluminium just a few centimeters thick.
Once the gondola was sealed, the pilots would be kept alive for up to 10 hours by an air recycling system, evolved from submarine technology.
Once inside, the oxygen was supplied by liquid oxygen evaporating from a container, and the carbon dioxide was scrubbed from the atmosphere by a reaction with soda lime.
In 1931, a huge hydrogen-filled balloon successfully launched Piccard and his assistant to over 15,000 meters. In doing so, the two aeronauts became the first men to successfully break through to the stratosphere.
It's incredible to think what it must have been like for those two men to look out of this tiny porthole and see for the first time the curvature of the Earth stretching out beneath them. Outside it was freezing cold, it would have been impossible to breathe. They really were incredibly brave pioneers of their time.
And as Auguste Piccard safely descended to the mountains of Austria, there was no doubting that he had shaped the future of high-altitude travel.
Picard predicted that one day we'd all fly high in the atmosphere, above bad weather and where the air resistance is lower. And without his pioneering gondola experiments, commercial air travel and spaceflight would just be a dream.
Ultimately, faced with a manned mission to Mars, Orion will be travelling 6 million times further than Picard's pioneering two-man gondola. This epic journey will require a supersized capsule for up to 4 astronauts, creating a huge challenge for Lockheed Martin's Crew Module Senior Production Manager, Mark McCloskey.
Mass is gold, because any ounce I can save in building the structure is an ounce of an astronaut, is an ounce of something going to space.
To save weight, designers are focusing on the inner shell. Like Picard's gondola, it's constructed of aluminium, but a super lightweight lithium alloy is allowing engineers to build NASA's largest ever capsule.
Some people will compare this crew module to Apollo. However, this is 40% larger than Apollo.
Lockheed Martin's engineers are currently assembling the project's latest pressure test vessel at the Michoud facility in New Orleans. Each of the 7 giant sections that make up the 5-meter wide structure have been machined for up to 6 months, reducing the metal's weight by up to 90%.
This is the aft bulkhead for the actual exploration mission vehicle. It's got a lot of pockets to add strength for the least amount of weight.
But to ensure the astronauts' safety, this huge capsule must become completely airtight.
This crew cabin structure has to stay together, not leak, perform flawlessly on its mission.
To achieve this, engineers are facing another historically challenging side to the construction process.
When people talk about welding, they think heat. They see a torch, they see a rod, and they see sparks. And that was welding. You know, that's fusion welding, heat.
But this time-consuming traditional technique can cause the metal to deform as it cools. So NASA's engineers have come up with an ingenious solution. Seamless joints can now be created in a matter of minutes, thanks to groundbreaking state-of-the-art machinery.
In friction stir welding, you never actually melt the metal. You get to a stage called plasticizing. So you're actually rubbing against the metal, heating it up, but never reaching the melting point, forming one solid piece of metal across.
But as well as being airtight, for the capsule to succeed, it will also have to provide a life-sustaining environment for its astronauts. To achieve this, engineers are creating the 21st century version of Picard's air recycling system. They're currently developing NASA's largest ever state-of-the-art service module. Once mated with the crew capsule, its supersized twin liquid oxygen tanks will provide astronauts with breathable air at sea level pressure.
The life support systems include oxygen regeneration, maintaining temperature, maintaining humidity. So things you never think about on Earth because the environment takes care of it for you.
And in order to power these systems for up to 3 years in deep space, engineers are once again breaking the mold, developing 4 giant solar arrays capable of providing a staggering 11 kilowatts of power.
When you look at the combination of the crew module and the service module, you're looking at a very advanced piece of engineering, a true state-of-the-art machine.
But to create a spacecraft that can truly transport man to Mars, its designers and engineers face more major challenges and have to turn to the innovators from the past for inspiration.
It's a piece of engineering genius that's incredible for a piece of equipment that was designed in the 1700s.
To produce even more impossible engineering. The Orion Spacecraft will be the most advanced exploration vehicle ever built. designed to transport man into deep space for the first time.
Orion is ultimately the future of space flight for humankind.
And for crew module manager Lara Kearney, the project's ultimate destination is the holy grail of space travel.
Being able to get the crews to Mars will be an important part of being able to answer whether there either was or is life on Mars.
But at over 100 million kilometers away, one of the biggest problems facing engineers and astronauts is making sure they can locate the awe-inspiring planet.
Unfortunately, it is very easy to get lost in space. The task of navigating to Mars gets progressively harder the further away you go.
We only have so much fuel on board. If we get a little off target and we don't have the fuel to get back, that obviously could mean a loss of our crew.
And with the stakes so high, in order to navigate safely through deep space, the team at NASA need to call on another genius innovation from the pioneers of the past. For the ancient mariners, the vast oceans offered a similarly enormous navigational challenge. Most kept land in sight, but in the 9th century, a Viking explorer ventured further afield with a cage of ravens. On releasing a bird, if it took off in a clear direction, he knew it was headed toward land. For centuries, Mediterranean sailors were guided by the direction of the wind, confident they could recognize a chilly northerly or a sweltering southerly. But they found a still day would leave them all at sea. Fortunately, a more effective navigation solution was on the horizon. Physicist Andrew Steele is heading out to sea to investigate.
With no accurate means of navigation, early voyages across our vast oceans were either for the very brave or the very foolhardy. Once you'd lost sight of land, it was very hard to know exactly where you were.
Although mariners could estimate the direction they were travelling in from the sun's position in the sky, pinpointing their position was impossible.
In order to know precisely where you are, you need to know your line of latitude and also your line of longitude. That's this grid of lines that covers the whole surface of the globe. And it wasn't until the 18th century that instruments were developed which allowed us to do this precisely.
In 1757, famed mathematical instrument maker John Bird created an innovative device that would change the face of navigation.
This is a modern version of Bird's device. It's called a sextant. It works by allowing the user to measure the angle between different objects in the sky and the horizon, things like planets, the moon, the sun, and the stars. The sextant enabled seafarers to determine their location anywhere on the globe at any time of day or night to an accuracy of just a few hundred meters.
To see just how effective it is in today's world, Andrew will be testing Bird's ingenious device against modern GPS.
To work out our latitude, I'm taking what's called a noon sight. You look through this little telescope here at this thing, which is called the horizon glass. It's half glass and half mirrored, and that means you can look straight through the transparent half and look at the horizon. Then this mirror works in conjunction with this second mirror to reflect the light of the sun into the viewfinder. Now, by changing the angle of this second mirror, we can then bring the sun down onto the horizon. And when we've done that, we can take a reading off this scale.
But to get an accurate idea of position, mariners still needed more information. And this was first provided by the Royal Greenwich Observatory Nautical Almanac in 1767. Sailors could simply combine their own calculations on board ship with those recorded from the world-renowned observatory.
By comparing the position of the sun at local noon to the position of the sun in Greenwich on the same day, using a guide like this almanac, we can determine our line of longitude.
Providing both latitude and longitude, these ingenious innovations have enabled seafarers to plot an accurate course for centuries. But how will this historic navigational technique stand up against modern technology?
So I've taken that noon sight with the sextant, I've done the calculations, and it looks like our latitude is about 49 degrees and 55 minutes. Our longitude is 5 degrees and 27 minutes, and all that comes out to within less than 500 meters of the reading we get on the GPS.
John Bird truly made the impossible possible.
The sextant is a piece of engineering genius that has remained almost unchanged since John Bird's day. In fact, merchant ships in the Navy still carry sextants as their means of navigation. That is incredible for a piece of equipment that was designed in the 1700s.
As Orion focuses on its first test flight in 2014, it will have a host of new technology to call on as it navigates through space.
First of all, of course, we have the Deep Space Radio Network, which is ground-based tracking equipment from Earth dishes that uses the information carried in a radio signal to actually navigate the spacecraft.
But in future missions, as the capsule heads further away from Earth on its 9-month journey to Mars, like their nautical predecessors, its crew will increasingly have to look to the stars.
NASA has a very good understanding of stars and their relationship to one another. There's been a lot of mapping of the universe to understand where the stars and the planets are.
As radio signals weaken, the astronauts will need to turn to astronavigation, taking their own measurements to establish their position in deep space.
The further out you get from Earth, the more diligent you have to be of milking every piece of information.
Faced with this huge challenge, Greg Holt and his team are currently testing an innovative onboard system in NASA's state-of-the-art optical tunnel.
So this is the Orion Optical Navigation Camera System, and the camera is actually looking at a simulated image of the moon that's not unlike the image that it would be taking in space. We're going to run that through the image processing routines on board to actually extract measurements.
This sophisticated equipment will calculate critical dimensions such as the diameter of the moon and the angle of separation between the moon and the stars, allowing astronauts to plot their location to a matter of meters.
It's the newest way to determine where your spacecraft's position and velocity is in space.
But as engineers continue to develop their mind-boggling technology, there are real concerns that the high levels of radiation in Mars's hostile environment could affect Orion's onboard computer systems.
If that were to happen at a critical time with a crew on board, it could be a very bad day.
So, as with many pioneers from the past, NASA's astronauts will turn to John Bird's ingenious 18th century navigational invention.
For the first few flights, we'll also have them carry along a sextant. They can take these measurements between the moon and the stars, good enough to get them back home safely. The idea that we're still able to use a sextant is really astounding. You can feel the salt air as you're in the spacecraft and hear the ghosts of the mariners past whispering to you, giving you advice on how to take a good sight.
But the navigational challenges facing engineers don't end there. Orion's 100 million kilometer voyage to Mars is so immense, it will have to be done in a series of gigantic space hops.
Once we're out of Earth orbit, we're going to have to dock to a habitat if we're going to stay out there for any period of time. Well, you have to be able to get into other vehicles or get out of that vehicle when you get there.
And with multiple dockings to support vehicles and even asteroids predicted, it's Frank Moore's job to create NASA's first ever automated docking system.
We can actually get the crew to a habitat without them flying it themselves.
Current tests at Lockheed Martin's Space Operations Simulation Center are replicating these complex maneuvers that would normally take up to 5 astronauts to perform.
So what we're doing now is simulating the motion of a final approach to a destination to see if the navigation system can actually correct the vehicle motion
In space, both the capsule and the destination it is docking with will be traveling at immense speeds. So the critical approach will be achieved by a series of laser-guided sensors.
The closing velocity has to be very slow, typically about 1/10 of a foot per second. But we're traveling at 17,000 miles an hour. We have to be within a couple centimeters of accuracy. You don't want to come in too hard because you can then damage the docking port. There's no spares. They don't grow on trees.
But Orion will face an even bigger challenge on its astonishing missions. To safely return home, designers will have to look to yet another ingenious innovator from the past.
Yes! That's massively increased our surface area, and we've decelerated phenomenally.
To create yet more impossible engineering. Engineers around the world are joining forces with NASA to develop a groundbreaking space exploration vehicle.
The name Orion will be up there in the annals of history with Mercury, Gemini, Apollo.
Ultimately, in 2035, the audacious project hopes to achieve the seemingly impossible goal of taking man to Mars.
Orion will usher in a completely new era of space exploration, being able to take crews farther than we have ever been before and bringing them home safely.
But crew module manager Lara Kearney is well aware that the final leg of the deep space mission will be perhaps the most challenging.
This will be the first time we have ever brought anything back from the surface of Mars, particularly something as big as the Orion Spacecraft.
As it enters Earth's atmosphere, Orion will be traveling 35 times faster than a speeding bullet. Its state-of-the-art heat shield protecting the crew from temperatures hotter than molten lava. But once the fierce heat of re-entry is negotiated, engineers face one more huge problem.
We're still going very fast, thousands of miles an hour, so it's a very big challenge to be able to slow down a 20,000-pound vehicle all the way down to 20 miles an hour.
This seemingly impossible task is down to Parachute Assembly's chief engineer, Koki Machin.
It's very difficult to make measurements on something that's deployed at 100 miles an hour. That has a lot to do with why they're considered the least reliable piece of the spacecraft.
Despite Orion's ultra-high-tech mission, to complete the final stage of its flight, engineers must rely on the simplest form of engineering. The fascination with defying gravity really took off in the early 1900s. The first freefall jump in 1919 transformed parachuting into a sporting spectacle, allowing early parachutists to discover new techniques. But it was the need to drop cargo and deploy troops during the First and Second World Wars that would ultimately drive engineers to push the boundaries of this vital piece of life-saving equipment. To experience firsthand the forces involved in returning to Earth safely, physicist Andrew Steele is 4,500 meters above the British countryside.
When we jump out of the aircraft, there'll be two forces acting on me and George. Gravity pulling us down, and air resistance pushing us up. And the air resistance gets larger the faster we go. So eventually we'll be going so fast, the force of air resistance will balance the gravity pushing us down, and that means we'll have reached what's called terminal velocity.
For an average man or woman, this constant speed levels out at around 200 kilometers per hour after 15 seconds of freefall.
Here we go! So we've just gone below 1,500 meters. We pulled the cord, and the drogue chute, which is stabilizing us during the free fall, has pulled the main parachute out of the bag. That's massively increased our surface area, and that means we've got much, much more air resistance than before, so we've decelerated phenomenally.
But if you want to slow down a much larger, faster moving object, a solid canopy like this will be ripped to shreds. This was a problem first faced by the Luftwaffe's engineers during the 1930s, as they struggled to control the landing speed of their newly developed jet aircraft. The solution was down to the genius of a young German engineer, Theo Nack. His innovative ribbon parachute would revolutionize high-speed air travel. Its ring-shaped canopy was broken into a series of vented ribbons, allowing enough drag to slow the aircraft down, but leaking enough air to reduce the stresses on the canopy. Aircraft could now land on shorter runways, decelerating from higher speeds faster and safer than ever before. Heralding a new era in man's fascination with air travel that lasts to this day.
Oh. That is an incredible piece of engineering. It's revolutionized aviation and saved countless lives. Oh, man, it's good fun too.
Nearly 80 years after its invention, NASA's Orion project will still rely on the historic ribbon parachute design. But as the largest capsule NASA has ever built returns to Earth, Theo Nack's ingenious invention will need to be supersized.
This parachute is the final phase of landing. This is one of a cluster of 3 parachutes.
These colossal mains each measure 35 meters in diameter, making up just one part of a state-of-the-art staggered parachute system. But equally impressive is the engineers' solution to testing. In July 2012, they embarked on their first low-velocity airdrop.
The proper test would be a spacecraft, rather expensive. So what we've been able to do is integrate our parachutes into something that looks exactly like the spacecraft and then practice deploying.
A total of 11 chutes will be needed to gradually slow the capsule down from a speed of around 560 kilometers per hour. The 7-meter drogue chute's simplified ribbon design stabilizes the craft, reducing Orion's velocity down to 160 kilometers per hour, before the pilot chutes pull out, deploying the 3 colossal mains.
When you look at a main, you can look at the fabric in here, and if you go calculate the surface area of this parachute, it is roughly 12,600 square feet. So think about your house or your apartment. How many of those would fit in one of these is impressive.
Thanks to the ingenious design of these gigantic chutes, Orion's speed will be cut to 1,000th of its outer space velocity in a matter of minutes.
By the time we get to the water, we're in steady state descent. When we hit the water, we're traveling roughly 20 miles an hour.
But despite its incredibly controlled landing, Orion's designers are leaving nothing to chance. January 2012 marks the latest in a series of tests at NASA's Hydro Impact Basin in Virginia, as engineers carry out extensive water drops, simulating potential splashdown scenarios in the Pacific Ocean. A variety of entry angles, wave heights, and wind directions are taken into account to ensure the self-righting capsule will not be tripped up in the final moment of its historic voyage.
We are committed to 100% mission success. That means the crew is always safe, and we get everybody back home safe.
Finally, after years of development and testing by thousands of engineers, December 2014 marks Project Orion's first major milestone.
5, 4, 3, 2, 1. And liftoff. The a new era of American space exploration.
As it embarks on its first unmanned test flight, the state-of-the-art spacecraft soars to over 5,500 kilometers.
We're back in space business now.
Oh, yeah.
During its 4.5-hour mission, the capsule faces a variety of hostile environments. As it passes through Van Allen's belt, it's exposed to prolonged periods of radiation before being subjected to temperatures in excess of 4,000 degrees Fahrenheit. But despite these incredible stresses, critical data confirms that Orion's maiden voyage into Earth's orbit is a resounding success.
The Orion Spacecraft and all of the thousands of people that are working on it are making what we thought was once impossible, a possible dream.
But to make its mark in history, Orion's designers now have their sights set on taking man into deep space.
This is a tough task. We're up to it.
I think once we finally do it, we could look back and say, this is the greatest thing we've achieved.
By drawing on the innovations of the past, adapting them, improving them, and making their own discoveries, these groundbreaking engineers are determined to one day make the seemingly impossible possible.
Standing on another world, you can almost not wrap your head around that.
Awesome!
I have no doubt that Orion will be that next great leap for mankind.
Flash down right now.
1692922.